Hello everyone and welcome back to our channel. In today's video, we are diving into the essential techniques of text preprocessing using Python and its libraries. Text, process, text preprocessing is a crucial step in any natural language processing task. It helps us in cleaning and preparing textual data for analysis. This step is before doing any analysis so that our data is clean and we are ready to extract some insights from our data. So let's get started. So first we will be installing the libraries and we will be importing nltk library for this task. To install this library, you just need to run this command pip install nltk and then just download its sets or functions. So you can easily run these two things and you are good to go to the next step. So here I have imported some of the functions of from nltk library like stop words, tokenizer, lematizer, stammer related functions. We will be using one by one in this notebook. Our first step in this data cleaning is decontracting. We will demonstrate how to expand contraction in text using regular expression. For instance, converting they are into they are for better analysis. So here I have defined some of the regular expressions, and to use or to define a regular expression you need to define like re dot sub and then define your specific characters or string and then how to replace with that. Like for example, I want to replace apostrophe ll into will, apostrophe t into not, apostrophe ve into have. So as soon as I run this function and I run this sentence, so it will convert they apostrophe re into they are working hard. So it makes your sentence better to interpret and to do and to move to the next stage. So that's how you do decontraction on textual data. So the next function is removing numbers. We will in this technique we will learn how to eliminate numbers from the text, ensuring our data is purely text based. Say goodbye to numbers in sentence like these are 5 people working in that area. So as soon as I run this cell, number 5 or numbers will be removed from this sentence. And to do that, we are just simply passing our sentence into this function and it's breaking or splitting by space, and then we are using regular expression here to make sure to just include words or characters and exclude everything and just focus on the characters. So as soon as it did that, it then appends each word into a new sentence, and it's basically creating a new sentence without numbers. So here we have these are people working in that area and number 5 is removed from this sentence. Next we have removing urls. Urls are often clutter our text data, so we will show you how to get rid of them. And to do that, we are again using regular expression and we are just defining here to exclude wherever this thing is coming with an empty string. So if a sentence or if a word or if a phrase is starting with http, it will make sure or it will replace this with an empty string. So you see it removed that url whole url, and if we add another words inside this text data like uh, subscribe to my channel, so it will have only subscribe to my channel and it will not have the url. So this is how you will remove url from text data. Next we have punctuation. Punctuation are like characters, like colon, semicolons, question mark, XYZ. So let's suppose we have got a URL or a sequence of words, and then we have got a different characters which are punctuation. To remove that, we can use string dot punctuation and save it into a variable, and then just pass the word like the string, and then call dot translate, and in that use dot make translate to replace all the punctuations. And as soon as I did that, it will remove all the punctuation from this text data, and including the one which are in HTTP as well. So we don't have any characters which are punctuation, and all are removed by empty string. So this is how you deal with punctuations. Next we have stop words. Stop words can be distracting in text analysis. We will show you how to eliminate these common words like the, and, is, and so on from our text data to focus on meaningful words. So the idea is to focus on meaningful words and to discard all the um, basic words like and, the, is, and, etc. So to do that, I have created a function called remove stop words, and we are passing our text data, or you can say words, one by one. In that function, we are splitting the whole sentence by words, and then we are checking if a word is present in the stop word list. Stop words can be imported using stop words dot words English. Every language have different types of words which are stop words. So we are specifying only English words, and we are saving that into stop words. Then we are just passing our sentence into this function, and it will make sure that it will give you or return you the proper sentence after you run this. So as soon as you run this cell, you will get more precise words, and it will remove will be in the, so this the didn't remove because it's a capitalized form and it's a start of the sentence, but we get rid of in the, so we can for these type of words, and we are only have focus, or we can focus on the important words which are used in this sentence. Next we have lemmatization. Lemmatization and stemming are both interrelated, and they are very essential for text normalization. We will see how these techniques reduce words to their root form, and its basic idea is to do better analysis. So here we are importing the NLTK libraries WordNet Lemmatizer. You remember we import WordNet Lemmatizer from NLTK library, and port stammer, which is used for stemming, from NLTK library. So here we have got WordNet Lemmatizer function, saving it into a Lemmatizer, and then we are just doing the exact same thing which we were doing for stop words, to split the whole sentence into words and to check each word whether it's a stop word, whether it's a Lemmatizer, whether it's a stemming word. If it's true, then Lemmatize that word. So you see the lockdown restriction, drop summer go traveling again. So here if we compare with the original one was the lockdown restrictions, so it removed the restrictions to restriction, and rest of the words are same. But for these words, walk becomes walk, walking becomes walking, walk becomes walked, walks become walk, ran becomes ran, run, running, runs, run. So it basically making sure that the any word which shouldn't be like ending with s or any type of characters, and if it ending with s, it will make sure that it comes back to its root word. Now let's check semitizer stammer example. So here we are doing the same thing. We are passing our list of words to check which words like which word go to the root word. So stem behave a little bit different. So as soon as I run it, walk becomes walk, walking becomes walk, walked becomes walk. So you see the difference. Lematizer was not changing the ed or ing, but stammer is changing the ing and ed into its root word. Same goes for running and runs. So you get some basic idea of how lemmatizing and stemming works and how to use this in Python. Next we have normalization. Normalization is basically to lowercase or uppercase your sentences. So if I run this sentence, it basically lowercase all the letters, and if I use upper, it will uppercase all the words which are used or all the characters which are used in this sentence. Next we have mentions. To remove mentions, like if we are uh, tweeting something and we mention someone and we need to remove that, and we just want to focus on the tweet part or the description part, we can use that. So here we are using regular expression and we are defining that only those words which are starting from at the rate, remove that from our sentence. And you see all the words like DD News, Nitesh Kumar, Narendra Modi, these type of words are removed from the sentence, and we have got only the tweet which used in this text. Next we have URLs. So if you have got a URL, we already see the URL, but this is another example. If you have got a URL inside a text, you can easily do this by regular expression. And at the end, we have got hashtags. If you want to remove hashtags from the tweet or any type of post, you can use regular expression. You just need to define expression which is starting from hash, and it will make sure that it shouldn't be include that hash words like slab was removed. Same for labor, same for labor leadership as well. So we have got the main text and it exclude all the hashtags. And there you have it, a comprehensive guide to text preprocessing using Python libraries comes to an end. These techniques are fundamental for any NLP related project, allowing for cleaner and more accurate text analysis. Thank you for watching, and don't forget to like and subscribe and hit the notification bell button for more exciting tutorials. See you in the next one.